to heaven, have you?
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Hello all.
Hello,
Let me introduce myself. My name is Andi Ahira.
my name is Dayang Anisa Safitri
My name is Denzel
My name is Audriana Septiani.
I'm from Heaven Group.
from Heaven Group,
from Heaven Group.
We are from Heaven Group.
International Management Class FEB Untan.
And I'm in charge of explaining the definition of linear function, also explaining one of the example question of linear function.
I will explain to you about the basic formulas of linear function.
In this time, I will explain the example of linear function.
And I'm in charge for explaining the implementation of linear function in economics and business.
Before I explain the definition of linear function, we have to remember that in mathematics, function is a relation with the property wherein every input, which is x, is related to exactly one output, which is f of x or y. Now, a linear function is defined as a function that has either one or two variables without exponents. Generally, it is a polynomial function with the maximum degree of 1 or 0. A linear function forms a straight line in a coordinate plane or in a graph. It can be horizontal, vertical, and in mathematics, linear actually means straight. So it could be easier to remember. All linear functions are written as equations and are characterized by their slope and y-intercept. The linear functions are also expressed in terms of calculus and terms algebra.
After mention at all about the definition of linear function, I will come to the pattern. The pattern consists of 4 parts. First, slope-intercept form. The pattern is y equals mx plus b. In the equation, y equals mx plus b for a straight line. M is called the slope of the line and b is the y-intercept of a line. Y is how far up or down is the line. X is how far along is the line. B is the value of y when x equals 0 and m how steep the line is. This is determined by m equal difference in y coordinates or difference in x coordinates. Note that difference in y coordinates is indicated as rise or fall and difference in x coordinates is indicated as run. The second one is point slope formulas. The pattern is y minus y1 equals m in the bracket x minus x1, where x and y is a random point on the line, which should be kept as variables while applying the formulas. x1 and y1 is a fixed point on the line, and m is the slope of the line. Third, standard formulas. The pattern is ax plus by equals c. And the fourth, intercept formulas. The pattern is x divided a plus y divided b equals 1. Okay, that's all. Let us see how to use the linear function formulas in the following solve example section that will explaining by Audriana Septiani and Andi Ahira.
So the first question is, now fx equal ax plus b. If f5 equal to 25 and f9 equal to 41, find the value of a and b. First, we write down the information that we get from the question. f5 equal to 5a plus b. This is according to the formula. And the result is 25. Next, f9 equal to 9a plus b. It is 41. Then to answer this question, we need to find the value of A. To find the value of A, we subtract F5 and F9. FA plus B equal to 25. Then 9A plus B equal to 41. Therefore, the result is minus 4A plus B equal to minus 16. 4A equal to 16. 16 divided 4. So the value of A is 4. Next, to find the value of B, we can substitute the value of A into the equation. Because there are two equations, I choose the first equation. It is 5A plus B equal to 25. It is mean 5 times 4 plus B equal to 25. 20 plus B equal to 25. B equal to 25 minus 20. So the value of B is 5. The second question is draw a graph of a linear function f(x) equal to 2x plus 1 with the domain minus 1 smaller than equal to x smaller than 3x element integers. So the domain are minus 1, 0, 1, and 2. To draw a graph, first we need to find the coordinate point. To find the coordinate point, we need to substitute the domain into the formula. If x equal to minus 1, it means f(x) equal 2 times minus 1 plus 1. It is minus 1. Second, if x is 0, it means f(x) equal 2 times 0 plus 1 equal to 1. Next, the third is if x equal to 1, it means f(x) equal to 2 times 1 plus 1 is 3. Last, if the x is 2, it means f(x) equal 2 times 2 plus 1, and the result is 5. After find the coordinate point, we draw the coordinate point in the graph and then draw a line. And yeah, this is the result of a linear function graph of f(x) equal to 2x plus 1.
I'm also going to explain the example question of linear function to make it easier for you to understand how to calculate linear function. So this is the question. If a linear function is f of x equals 4x plus b, determine the form of the function if it is known that f of 6 is 8. So remember that a function is relation between input, which is x, and the output, which is f of x or y. After it is known that f of 6 equals 8, we can put this into the function of the question, which is f of x equals to 4 times x plus b. If we put the numbers into the function, it will look like this. F of 6 equals to 4 times 6 plus b equals to 8. And now we can start to calculate the function. So 8 equals 4 times 6 plus b. And we can start to calculate it. 4 times 6 is 24. So we can write it like this. And it becomes negative because you change the 8 from here to here. So it will be b equals 8 minus 24. So the result will be b equals negative 16. So the form of the function, it will be f of x equals to 4x minus 16.
Business managers use linear equations to find the cost, profit, sales, loss, and break-even points of a business. The break-even point of a linear equation is where the equations intersect. Cost is how much you pay for the item, and profit is how much you get after break-even. And revenue is the funds raised. Linear functions that are commonly used in economics include the demand function, the supply function, the inverse demand, inverse supply functions, the budget line, the iso cost line, the average return function, the marginal return function, the consumption function, savings function, the aggregate demand function, and others. However, some of these functions are also nonlinear. In general, the marginal cost function and the average cost function are U-shaped. However, marginal and average cost functions may also be linear. Linear functions in economics have all the usual properties of linear functions. However, in some cases, the economic variables are never negative. For example, quantity, price, capital, labor, and others cannot be negative.